This is the basic setup for our acceleration on a ramp activity. This activity combines two of our previous activities, the one where we did forces on the ramps, where we measured the horizontal and normal force on the boards and changed the angles, and the Newton's second law with a constant mass activity where we measured the acceleration, where we found the relationship between the acceleration of the cart and the force of gravity pulling down on the second mass, which was, in that case, if we ignore friction, which was our net force. In this case, we're going to have a ramp with an angle, and we're still going to have a mass hanging down on the end, and we're going to do some calculations where we assume no friction, and then we're going to see how accurate we are, and then we're also going to see if we can determine what the force of friction is. There's two possibilities of what's going to happen here. Depending on this weight, I can start the cart on the bottom, I can put a heavy enough weight hanging here, and it will pull the cart up the ramp. But we also will have some examples where this weight isn't heavy enough, so we'll actually have to start the weight at the bottom and then release the weight, and the cart will go down the ramp. And I'll show you an example of actually taking how we take the measurements for that. You want to make sure that this string is parallel to the ramp, otherwise if the string's pulling down or pulling up, so you may have to adjust the setup here, adjust the ramp. There's a weight here holding it down, so you can adjust this up and down. In fact, you'll definitely have to as we change angles. We're going to do the angles of 10, 20, and 30, as you've probably already seen in your lab notebook if you've looked at those pictures. For smaller angles, you'll probably have to do something like this, because if you set this on the ground, there's not going to be enough room for the weights to drop and pull the cart so we can get measurements. But if you put the stand all the way down, it won't reach the edge of the ramp, so you'll need to set something up like this. Move your cart on the table. This may be how it winds up, depends on your lab, so that the other class may leave it on the floor, and you'll need to put it up on the table and set your angle at 10 degrees. At 20 degrees, you may want to do it this way, you may want to do it on the floor. You'll have to experiment with that and use your best judgment. Since we're using the pulley and the photo gate combination, as we've seen before, your timing will be in motion, but you need to make sure you're set on the pulley spoke. If you're getting bad data, that's the first thing to check to make sure this was already set on pulley. A lot of times if you just turn your LabQuest on, it'll be on the vernier picket fist, so you make sure it's set on pulley, and then you can hit OK. Here's an example of how you actually collect the data, as we've used this kind of setup before. So you've got the string going over the pulley connected to the photo gate. You hit the green play button, and then it will sit and wait until the pulley moves. Then after you do that, you just release the weights, and I think all these weights are small enough that you'll not have big crashes, and then you can just stop the LabQuest and then you look at your data. If the hanging mass is not heavy enough to pull the cart up the ramp, then you'll set it up this way. You'll have to hold the weight down with your hand. The cart will be part way up, and it doesn't have to drop that far. You just need enough distance for the cart to move far enough to give you a line on your LabQuest. Then you hit the green button, and once it's ready, you let go, and the cart will slide down, and then you collect your data. Once you collect your data, it's going to look like this, as we've seen before. Now the line I want right here, I find that hard to highlight, so I'm going to change my right hand number to something about half of what it was, so 2. Then I hit done and I hit OK. Now I have a much easier time to highlight that and analyze it. You're going to use the curve fit, so you go to Analyze after you highlight it. Do not get the very first and very last point. That probably gives you a little better data. I go to the velocity, and I go to the curve fit, linear, and this slope should be my acceleration. Keep 2 decimal places, 2 significant digits to the right of the decimal place. So in this case, this would be 0.70, which is actually the data that's in the practice lab that I showed you. This data actually comes out to be pretty accurate. So this is a good lab to get accurate data with.